Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on November 4th, 2025, just yesterday. The big idea is that this paper introduces MIRA, a benchmark showing that giving models intermediate visual cues boosts accuracy by about 34%, while text-only chain of thought often falls short. The paper is titled, When Visualizing is the First Step to Reasoning, MIRA, a benchmark for visual chain of thought, and the implications for model training are quite significant. Alright, Figure 1 makes the point that visualizing steps is crucial for correct reasoning. The left side shows a dice path problem where a human sketches the imagined roles, which illustrates visual chain of thought as drawing intermediate states to guide logic. The right chart shows strong models, scoring well on familiar benchmarks, but staying under 20% on MIRA. Together, these panels argue that text-only reasoning misses key spatial information, so intermediate visuals lift performance. Alright, Figure 2 maps the benchmark into two task modes, static single-step and dynamic multi-step. Visual chain of thought means models draw intermediate images that guide their logic, like sketches or path states. The panels showcase diverse problems across geometry, physics, spatial puzzles, and causal transformations. The dataset provides 546 problems with paired questions and images to evaluate direct, text, and visual prompts. There are 936 intermediate visuals that capture single clues or stepwise sequences, which enables automated scoring. So Table 1 reports head-to-head results across models and input types. The big takeaway is that providing visual chain of thought, meaning intermediate sketches supplied to the model, consistently boosts accuracy. Overall averages stay below 20% with direct inputs, which signals the benchmark is hard. Visual chain of thought lifts physics tasks the most, roughly doubling some models' scores. Text-only chain of thought tends to stagnate or drop, while unified generative models still lag behind understanding-focused ones. Figure 4 shows how performance climbs only slightly when models get more chances to answer, because pass at K means sampling multiple attempts and counting any success. The stacked bars compare direct, text chain of thought, and visual chain of thought settings. Visual cues raise the base the most, while extra samples add small gains that taper off. The red horizontal marks show majority voting over 8 tries, which barely helps the strongest systems. Wrapping up, 2 takeaways stand out. First, reasoning benefits when models sketch intermediate visuals, delivering roughly 34% relative gains. Second, more sampling or text only prompts barely help, which signals a missing think while drawing capability. The broader implication is clear. Training must interleave generation and use of images during reasoning. Thanks for listening. I am Alex.